Let's look at exponential equation in this video. For you to understand this concept perfectly, check the description box below for the lecture on indices, also on the lecture on quadratic equation. If you can perfect that, then this will be very easy for you. Now take notes. Take a look. If I have 5 to the power of x equal to 25, you see, whenever you are having an unknown as your exponent, such equation is called exponential equation. That is, when an unknown is a power, then we are having exponential equation. Now, how do we solve all exponential equation? Now, take a look at these rules. Look at, if I have a to the power of m to be equal to a to the power of n. Now, what is between them is equal to. Therefore, it's an equation. Now, since we are having the same base on both sides, what happens? You can cancel out the common base, then m is equals to n. That is just the rule. What if I have a to the power of n equals to what? A to the power of n plus k. Now what we do from here, since they are having common base on both sides, you will cancel it out. Therefore, n will be equal to n plus k. And that is it. Okay, take for example, if I have 2 to the power of x to be equal to 8. We all know that 2 to the power of x is equal to 8. Another way to express it, to make the base 2, is 2 to the power of 3. 2 to the power of 3 is 8 because 2 times 2 times 2 will give me 8. Then, since I'm having common base, I will cancel it out. Then, x will be equal to what? 3. And take note of something. Look at this law. If I have a to the power of m to be equal to 1 over a to the power of n, never say this cancel this. It is wrong. Before you can do that, there must be on, this is at the numerator. This must also be at the numerator. Then I will apply law of indices. This is a to the power of n. This will be equal to what? A raised to power minus n. Remember, when I'm bringing this to the top, it will take a negative sign. Therefore, you cannot cancel out the base. So I have n equal negative n. Similarly, what I'm having here, I can write as 5 to the power of x equal 25 is what? 5 to the power of what? 2. Then what happens? This and this can equate. Therefore, x will equal to what? X will equal to 2. That is the basic concept of solving exponential equation. Now, since we've known this, let's go ahead to solve some challenging problem. All right. So let's take a look. Let's look at the first question. If I have 8 to the power of 1 minus y equal 4 to the power of 1 plus y. Now, what will you do here? Observe, there is no way I can make it as base 4, because if you say 4 to the power of 2, 4 to the power of 2 is not 8. 4 to the power of 2 is 4 times 4, and that is 16. So how will you do this? You observe that what? You can't express this as 4. But if you check, you can express it as 2. You can also express this one as 2. Do you remember 8 is the same thing as 2 to the power of 3? Then I'll replace this like this, 1 minus y equals to 4 is the same thing as 2 to the power of 2. Now replace this like this, 1 plus y. Now what will you do from here? This and this, you cancel them out. So I have 3, 1 minus y equal to 1 plus y. Then you can now open the bracket. 3 times 1 is what? 3. 3 times y is 3y equal 2 times 1 is 2 plus 2 times y is 2y. Now, this is 3. When plus 2 comes here, it becomes minus 2 equal, this is 2y. When minus 3y comes to this other side, you have plus 3y. So this plus this will give me 5y, and this plus this minus this will give me 1. So if I divide both sides by 5, y will be equal to 1 over 5, and that's the answer to that question. Next question. Observe this. If I have 1 over 5, 25 to the power of n equals to 25. Now, what will I do from here? I can have 1 over 5 multiplied by 25 is the same thing as 5 to the power of 2. That's 25. Then the n you have here, you replace it there. Equal to, this is 5 to the power of 2. So what I'm having here, if you check it out, you will see that I can write this as 5 to the power of 2n divided by 5 to the power of 1, because these are denominators, so it's dividing that. So equal to 5 to the power of 2. So this division, I will subtract the powers according to the law of indices. I have the same base and I'm having division, so I'll take one of the base and minus the power. So since that I have the same base, I'll cancel it out, so I'll have 2n minus 1 equal to 2. So 2n equal to, when minus 1 comes here, it becomes plus 1. 2n equals to 3. So if I divide both sides by 2, therefore n will be equal to 3 over 2. And that is the answer to that question. Now the next question is this. The next question is this. The next question is this. If I have 1 over 81 to the power of x minus 2 to be equal to 27 to the power of 1 minus x. Now, what do we do here? You observe that I've told us there's no way you can cancel out this and this. It's not possible. There's no way you can cancel out this and this. But one thing is that express both of them as something like 3 raised to power something. Do you remember that 81 is the same thing as 3 to the power of 4 and 27 is the same thing as 3 to the power of 3? Since we know that, I'll replace it there. So this one will now be equal to 1 over 3 to the power of 4, that's 81. Then your power, you replace it back there as x minus 2. Equal, you say this 27, replace it with 3 to the power of 3. So I have 3 raised to power 3, then you have your 1 minus x. Good. Now, after that, remember, I want to make this one comes to the numerator. And remember the law of indices. When this one swap position to the top, you are going to put a negative sign. So I'm having 3 raised to power minus 4 x minus 2 equal 3 to the power of 3 1 minus x. So what will I do from here? Since the bases are same, so I will equate it. I'll cancel it out, so I'll be having minus 4 x minus 2 equal 3 1 minus x. So we are going to open this bracket. So this is what you will do. Minus 4 will multiply this, and this same minus 4 will multiply this. So minus 4 times x will give me minus 4x. Minus 4 times minus 2 will give me plus 8. Remember, minus times minus is plus. Then this 3 will multiply this and this. 3 times 1 is 3. 3 times 3, 3 times x will give me 3x. Next, so I have minus 4x plus 8 equal 3 minus 3x. So what do you think I'll do from here? So I have minus 4x. When minus 3x comes here, you have plus 3x equal, this is 3. When plus 8 comes here, you have minus 8. So minus 4x plus 3x will give me minus x. 3 minus 8 will give me minus 5. So from here, minus, cancel minus. So I have x equal to 5. That's the answer to that question. Okay. Let's take a look at more challenging problem. Okay. What of if I have 9 to the power of 2x minus 1 over 27 to the power of x plus 1 equals to 1 over 9. Now, what will I do from here? It's very, very simple. You don't have to panic. You observe that I can express all of them as 3 raised to power something. So what will you now do is that, well, remember, 9 is 3 raised to power 2. So I have 3 raised to power 2, then 2x minus 1. 27 is 3 raised to power 3. So I have 3 raised to power 3, then x plus 1. equals to 1 over 9 is 3 raised to power 2. So this is what I'll do. Here, I'll apply my law of indices. Or, see, let me just break it down like this. 3 raised to power 2, 2x minus 1. This line here is divided by 3 raised to power 3, x plus 1, equals to, when this one comes up, it will become 3 raised to power minus 2. Apply law of indices here. The link is in the description box. If you are not that strong in law of indices, check the description box below for the video on indices. Then if you watch it, hopefully you understand it. So from here, what will I do? I'll pick this, then I'll have 2x minus 1, then minus 3, then x plus 1. So that is it. Then equals to 3 raised to power minus 2. So from here, what will I do? I'll cancel out this. Okay? So I have 2x minus 1 minus 3x plus 1 equal minus 2. So open this bracket. So I'll have 4x minus 2 minus 3x minus 3 equal minus 2. 4x minus 3x will give me x. Minus 2 minus 3 will give me minus 5 equal minus 2. So x equal minus 2. When minus 5 comes here, it will become plus 5. Then x will equal to 3. That's the answer to that question. X equals to 3. Let's solve more challenging problem. Sorry. Let's solve more challenging problem. All right. Okay. Assuming you're asked to solve this question. This question is, I have 16 to the power of 3x equals to 1 over 4, then 32 to the power of x minus 1. This is what you have. How will you solve this question? It's very easy. Remember, all of them cannot be expressed as 4. Of course, 4 raised to power 2 is 16. I have 4 here, but 4 raised to power what will give you 32? I don't know. So 2 will work. 2 raised to power what is 16? 2 raised to power 4. Multiply 2 by itself 4 times, you get 16. So I have 2 raised to power 4, which is 16. Then I have my 3x. 1 over, this is 2 raised to power 2. And what is 32? 32 is 2 raised to power 5. Then I have my x minus 1. So this is 2 raised to power 4. 4 times 3x will give me 12x, which is equal to, this will give me 2 raised to power 5x minus 1 divided by 2 raised to power 2. So this is 2 raised to power 12x equal, remember my law of indices, so I'll subtract minus 2. So since these are common, I will equate them out. So I have 12x equal 5x minus 1 minus 2. So 12x equal 5x minus 5 minus 2. So when this comes here, I have 12x minus 5x equal minus 5 minus 2 will give me minus 7. So 12 minus 5 will give me 7x equal minus 7. Then what would this give me? Divide both sides by 7. Then I have x equal minus 1. So that is it. That is it. So this is what we have. Now, these are the style of questions that you will see. The first aspect of exponential equation, where you just cancel out what is common, then find the value of x. But now, another type of exponential equation I will give us, it will actually lead us to a quadratic equation. Observe this question. 3 to the power of 2x minus 12, 3 to the power of x plus 27 equals 0. Now, when you see this type of question, it's an exponential equation. How do I know? My power is an unknown. Now, I'll start from here. Take a look at what I'm having here. I can write it as 3 raised to power x. Then I can put my 2 outside. Why am I doing this? Because I want it to resemble what we have here. Now, minus 12. This is 3 to the power of x. Then plus 27 equals 0. So you now say that let 3 to the power of x be equal to, I can say be equal to p. So here I have p square minus 12p plus 27 equals 0. Anywhere you see your 3 raised to power x, put p, and that is it. Now, what will I do from here? I'll solve this quadratic equation. So check the link in the description box for the lecture on quadratic equation. Now look at it. If I have 27, what are the two numbers I can multiply together to give me 27? And when I add them, I'll have minus 12. So they are what? Minus 9 and minus 3. So if I solve this, so I'll have p minus 9, p minus 3 equals 0. So p minus 9 equals 0, p minus 3 equals 0. So from here I'll have p equal 9 and p equal what? 3. So I've gotten my two values like that. So remember, the question asked me to find x and not p. So I'm going to recall this statement. Recall that you said 3 raised to power x to be equal to p. Now, when p is equal to 3, let me say when p is equal to 3, remember I have 3 raised to power x equal, p now is now 3. So this, take away this, so x equal to 1. Also, when your p is 9, what will you do? When p is equals to 9, what will you do? So you have 3 raised to power x equal 9. 3 raised to power x equal 9 is 3 raised to power 2. So cancel. Then x will be equal to 2. So my two values are x equal 2 and x equal 1. That's the two values of x. Now, whenever you get the value of maybe p or q, depending on the letter you are putting there, you have to bring it back to this statement and substitute those values. Next question. Okay, let's see. Another question. What of if I have 2 to the power of 2x squared plus 15x plus 7 equals to 1? Now, what will I do here? What I'm going to do here is this. I have 2 to the power of 2x squared plus 15x plus 7. Now, this one, what can I do? Remember that this one, I can rewrite it as 2 to the power of 0. Remember, a number to the power of 0 is equals to 1. So, I can equate this and this. 2x squared plus 15x plus 7 equal to 0. So, let's see, how do we solve this? Okay. So this will give me 14. So two numbers to multiply together to give me 14 is 14 and 1. And if I add 14 and 1, I will have 15. So I have 2x squared plus 14x plus 1x plus 7 equal to 0. Give me 2x. So I have x plus 7, 2x plus 1 equal to 0. So I have x plus 7 equal to 0, or 2x plus 1 equal to 0. So x will be equal to minus 7, or x here will be equal to minus 1 over 2 if I solve the equation. So that's that about that. Also, the last question for today. The last question for today is this. The last question for today is this. And the question is mostly common in exams. If I have 3 to the power of 2x plus 1 minus 4 times 3 raised to power x plus 1 equal to 0. Now, what will I have here? See, you see this part, whenever you are having a type of power like this, take note that according to indices, remember if I have a to the power of m times a to the power of n, that a to the power of n plus n, it means that if I'm having powers adding together, it came originally from something like this. So I can write this thing as 3 raised to power 2x times 3 raised to power 1. Because if I apply law of indices here, I will go back to this. 4, 3 to the power of x plus 1 equal to 0. Here I can write this thing as 3x to the power of 2, and I have 3. I can even put the 3 here because this is the 3. Then minus 4, 3 to the power of x plus 1 equal to 0. So I will now say let 3 raised to power x be equal to any number you want. I can say be equal to k. So I have 3, this is now k square minus 4k plus 1 equal to 0. Now I'll solve this. This will give me 3. Two numbers will multiply together to give you 3, and when you add them, you get minus 4. The two numbers are minus 3 and minus 1. Minus 3 times minus 1 is plus 3. Minus 3 minus 1 is minus 4. So I have something like this. 3k square minus 3k minus 1k plus 1 equal to 0. So I'm grouping 3k square minus 3k. And when you are grouping and there's a minus outside, you have to change the sign inside. You see, assuming the sign inside was also minus, it will have changed to plus. So just taking that with any minus here, we change this sign to the opposite sign. So 3k is common to both of them. If I take it out, I'll have this. Here, 1 is common to both of them, so I'll have k minus 1 equal to 0. So here I have 3k minus 1. I have k minus 1 equal to 0. So here 3k minus 1 equal to 0, or k minus 1 equal to 0. So here I have k equal 1 over 3, or here I have k equal to 1. This is what I have. This is what I have. So I have these values for k. Now remember that the question did not want me to find k, is x. Remember that you recall that 3 raised to power x equal to k. Recall that statement. Now after recalling that statement, then we solve. Now when my k is 1 over 3, when k is equals to 1 over 3, then you have 3 raised to power x equal k is 1 over 3. Remember, I can't cancel this and this, it will not work. So I have to say 3 raised to power x equal 1 over 3 is same as 3 raised to power negative 1. This cancel this, x equal minus 1. That's the first answer. And the second one, when k is equals to 1. So you have 3 raised to power x equal k. K is 1. And 3 raised to power x equal 1 is 3 raised to power 0. Cancel, then x is equals to 0. So these are the two values for x. Now, like this video, comment, subscribe, and share to your friends. Okay, before I end this video, there's actually something I want to call our attention to when we are solving exponential equation. What's that? If I have, look at this rule. A raised to power n equal minus a raised to power n. Do you think you can cancel this and this? Never. It is because what you are having here is plus, what you are having here is minus. Here, there is no solution. When I'm considering set of real numbers, there is no solution. But in the complex world, there will always be a solution. Take note of that. Now, that is it. Just take note that you need a solution. Just like if someone give you 2 raised to power x equal minus 4. Don't be tempted to say 2 raised to power x equal minus 2 raised to power 2. No, it's not work because this will not allow it. So here you just comment no solution. Okay? When x is a set of real number. But in complex world, there's always solution to all this. So that's that about that. Thanks for watching.